Hi, Research 9. This is an Excel specific video for organizing your data, and I'm going to add a couple tips and tricks and then show you how I would graph it. So if we go to Excel right now, what I have here is a data set that is fake, but looks like how many of you organized your data. I had this set up for you with your incongruent times and congruent times and the Stroop effect here, which is supposed to be the difference. It's supposed to be the amount of time that was, how much slower the incongruent stuff is, right? When you're saying green, even though the word says red, right? If you're just saying the color, if it's incongruent, it should take longer than the congruent. So many of you guys organized your data by participant so that it was a little bit more organized. So, some of you just have 3 trials per Ivy level. That's fine. Some of you have more. I wanted to include the more so it's a little inclusive of everybody. But a couple things first. One is calculating the Stroop effect. Most of you must have done your math on a calculator or something and wrote it down. But you can have Excel or Google Sheets either do it for you. So any sort of math that you want to do, Excel can do it. So if we want our cell to equal a number, so I left this one blank so we can do it together. Equals, so anytime I wanted to do math, I want to say this cell equals the result of the following equation. Equals, and I want this number, so that's D15, I'm going to click on that, it'll type D15. I'll type minus, and then I'll click on E15, and it'll type E15 for me. I could have typed D15 minus E15, but that takes me too long. And then I'll hit enter. Equals the difference of those 2 numbers, and it gives it to me. I could do that again. Equals, click, minus, and then click the other one, right? But again, you may have seen this before. The trick here actually is, because this is a formula of this number subtract this number next to it, I can actually copy and paste. So if I hover over the lower right-hand corner with make a little plus sign here, that's going to copy and paste. So I'm going to take this and drag it down 3. And not only does it copy and paste, it copies and pastes the actual formula and also relative to where it is. So this, you see up here, this one says D15 minus E15. This one says D16 minus E16. This one says D17 minus E17. It does it for you. Okay. We can do the same thing with the averages. So equals average, that's the formula for average, open parentheses, and now it's asking what numbers should Excel average. I'm going to click and hold and select all 3 numbers. And so it says D15 colon D17, it's the D15 to D17. Close parentheses, enter, that's my average right there. I could type that in for the next 2 if I wanted to, but I'm gonna actually go to this bottom right corner and drag across, and makes a nice number here. It's constantly calculating this number for us. So if I were to change one of these numbers, this 21.1, if I change it to 100, this average will change, right? Because it's constantly, this difference will change and this average will change. Anyway, that's what I have for all 4 of these things. Now, when you're analyzing the data, who's what participant doesn't actually matter. I just care about IV and DV, right? And our IV here is generic, and our DV is the Stroop effect. So actually, when I set up my summary table, I only care about the Stroop effect. I don't care about the incongruent and congruent times. I just want the difference. So I'm going to say I want my control. And so think of this like your x-axis, right? Your control is here. Your experimental is here. Maybe you have more than one experimental group and you make more columns. Yeah. And so control here, experimental here, and I'm going to put a title here, Stroop effect. So I know what these numbers represent. And because I want it to line up with both of these, I'm going to actually select both cells here and go up here. You see over here where it says merge and center? This is just a nice little trick. It'll merge these 2 cells together and make one big cell. And it's nice and centered. Okay. And then all I need then are my numbers. So I can take my Stroop effect control participant 1. Uh-oh, I've copied and pasted a formula That's no good because these are all 0 now because what they're doing is they're taking the difference of these two values. So that's not good at all. So what can I do? There's actually a couple different fixes here. My favorite, I think, is when I copy these, Control C, Command C, and then I'm going to right click or option click here, and I can do a paste special. And so I actually don't want to paste the formulas. I actually want to just paste the values. I could do that. And that's the actual numbers. I'm going to do again. Paste special values. Okay. These numbers are ugly because they haven't been rounded. So I'm actually going to go and round them up here. You can see this button here, decrease decimal. I'm going to decrease the decimal here. Oh, this is formatted funny. So I'm actually going to do Command A or Control A and center up everything. It's all down the middle. Okay. For my experimental, I'm going to do the exact same thing, but I'm going to actually take a little shortcut. I'm going to select this and then holding down, select these three, then holding down the Control or Command button, click and select this so I can actually select two discontiguous groups. Copy, that's Control C, and then paste values, and they're all right here. Now, some of you may want to, if you want to keep track of these, who's who here, there's nothing stopping us from labeling them. I just don't want to put anything other than numbers in these so that Excel knows how to deal with these numbers. So if it matters to you, if you want to be really organized, I could say participants here, and what would this be? Trial, right? And so participant 1 did 3 trials. Participant 2 did 3 trials. If that helps you understand what's going on, there's nothing wrong with that. And then what I'm going to do is I'm going to select all of these and add borders. It makes a nice table here. And so now I want my summary information. I want my mean, and I want my standard deviation. And for my mean, you already know how to do this. Equals average, open parentheses, select the numbers you want to average here. I'm going to copy and paste over here so it'll do automatically. Equals, for standard deviation, there's a lot of different standard deviation ones. I like to use, I'm going to tell you to use stdev.s. That's the sample standard deviation. Select the numbers, and it calculates that for you. Right, so we got a mean of 8.4 and 7.3 in the experimental, standard deviation 1.8 and 4.4 in my standard deviation. So this is great. This is the summary data. If I want to graph this, the even easier way would be for me to take these numbers and put it in a very simple table where it's just, because all I really need to graph is the averages and the standard deviations, which I've put here before, so you can see them, okay? This is all the information I need to graph, because remember, a graph is just a summary of what happened. So when I graph it, I'm just going to select Control Experimental and the averages. That's it. That's all the information I need to graph right now. Insert column. And then I've got this lovely graph here. Okay. Notice that on the, here, let's zoom in so you can see a little better. Or view, what am I doing? Notice that on this graph, the y-axis, the scale is pretty wacky, but actually Excel will fix that for us. So actually the first thing I'm gonna do before I do anything else is I'm gonna add my error bars, because it'll help correct this, this scaling problem. So how do I add error bars? Well, anytime I wanna modify the graph, I click on the graph, a menu will show up that didn't exist before, and it says there's a chart design one and there's a format one. I want to go to chart design, and this is your magic button here is add chart elements. This is all the stuff we'd want to add. We're going to want to add axis titles eventually, right? That adds these little text little text boxes here. You can see those. But right now we're going to add error bars here. And now you will be tempted to click on standard deviation here. But the problem is Excel doesn't know what the standard deviation is. You haven't told it what it is. It's just going to do a random guess. All this graph knows is 8.4 and 7.3, the two means. So this is actually not going to help us. We're going to go to more error bars options. Okay. And then again, so that up here, there's for error bars, this means like aesthetics. Okay. This is a special effects, which we won't ever use. And then over here is like the actual mathematical options. And so our error amount, it just made a random number. It just said 0.2. And so it's doing 0.2 above and below the mean on both these, but we don't want that. For our control, we want 1.8 above and below the mean. And for our experimental, we want 4.4 above and below the mean. We want plus or minus 1 standard deviation. So I'm going to make them custom. And I'm going to, so click here and then specify the value. It's going to ask, what's the positive error value? Positive error means above the mean. So above the mean, I'm going to delete what it says, and I'm going to select these two numbers. I'm selecting both because it needs to know that this 8.4 should correspond to 1.8, and this 7.3 should correspond to this 4.4. I'm going to delete. Negative error value should be the exact same, right? Above and below should be the same. Okay. And let's look at our graph. Hey, look at these error bars, and they're different. This is 1.8 above and below, and this is 4.4 above and below. So it actually looks really nice. I'm going to clean this up and make it look even better. We'll get rid of the horizontal lines by clicking on them and just clicking delete. We're getting rid of the title. We're not going to put a title here. Notice that the default options here are bad. So I'll click on the axis, and then look, some of this other stuff appears. And I want to play with the aesthetics of the axis because I want an actual line. I'll go to the paint can. Solid. No, I don't want to fill. I want a line. I want a solid line that's black. That should look better now. Yeah. And then over here, my y-axis, my x-axis also has a line, but it's gray. So I'm gonna make it a black line. Okay, that looks good. We're looking good. And now I just want to name my axes. So this one is Stroop effect in seconds. And then this one is whatever my independent variable was that generated these bars. So I'll write independent variable. I can play around with this. Like if we click on the bars, both bars will select, right? And I can go to the paint can and I can make them a solid fill and like make it kind of a lighter color so I can see my error bars better, and I'll put a black line around it. This is a nicely formatted graph. We can see exactly what's going on. And then all that I'm missing is a text box to explain what's going on here. So I'm going to call this figure 1. That's what figure 1. And then my title is the effect of IV on the Stroop effect. And then I'll write my description here, right? So I'll write graphed are the means of blah experiment, right? I can even indicate the number of numbers that indicate that where the means were given. So if I had, for each of them is the average of 6 numbers. So I'll do n equals 6. And then I'll just say error bars represents plus or minus standard deviation. So that means that this is my mean here, plus or minus 1 standard deviation. So we know that most of the data for this group is in this range, and most of the data for this group is in this range. And what I have here now is a nice figure, professional looking figure. And it only took me a couple minutes. This is not intuitive, so this may take you a little while to do. If you need any help, let me know. But this is how I want you to set it up. And that is that. All right, comment out.